Hello, Mr. Betts here. I want to take a look at an example of a parametric equation, and using calculus, we want to find the equation of the tangent line. So in the video where I introduced the idea of using calculus with parametric equations, I talked specifically about the slope of a tangent line, but ultimately, usually we're going to use the slope of a tangent line to write the equation of a tangent line, so we'll have to find that slope along the way. So let's start by thinking about how we're going to find the slope of this tangent line here. And remember that slope is given by dy dx. So slope of a tangent line is given by the derivative of y with respect to x. And with parametric equations, that's going to be the derivative of y divided by the derivative of x. And so we could write this as dy dt over dx dt, or in prime notation, it's going to look like this. I do want to point out that when we use prime notation, the variable that we are taking the derivative with respect to is usually not explicitly defined, unless we put this y prime of t. So that indicates then that it's going to be dy dt. Okay, so in order to get started here, I need to take derivatives. So I'm going to take the derivative of the x of t function and the y of t function separately. To take the derivative of x of t, we are going to have to use the chain rule here because we have this inner function in the sine function. So we take the derivative of the outer function. The derivative of 3 times sine is going to be 3 times cosine. We'll keep the inner function in there, so pi t over 4. And then we have to multiply by the derivative of the inner function. Remember, we are taking the derivative with respect to t, so that makes things pretty easy here for us. Sorry, let me get that back to where we were. So the derivative of that inner function is going to be pi over 4. So we're going to multiply by pi over 4, and I'm going to put that out front. So we get 3 pi over 4 times the cosine of pi t over 4. That's the derivative of x at any particular t value. For y, we'll do the same thing. So y prime of t, taking the derivative there, use the power rule, we're going to get negative 3t squared, and the 3's are going to cancel, so negative t squared plus 4t minus 2. And so specifically, we want to know what's the slope at the point t equals 3. So I'm going to find these values at t equals 3. So I want to know what is x prime of 3. So it's going to be 3 pi over 4 times the cosine of 3 pi over 4. Looks like we're going to get to do a little trig there. And we also want to know what y prime of 3 is. That one's going to be a little easier. So it's going to be the opposite of 3 squared plus 4 times 3 minus 2. So that is going to be negative 9 plus 12 is 3 minus 2 is 1. So that's nice and easy. Cosine of 3 pi over 4. So remember, 3 pi over 4, that's going to be in the second quadrant. Cosine is negative in the second quadrant, so I know I'm going to get a negative value. My terminal angle is going to be pi over 4. Cosine of pi over 4 is going to be 1 over the square root of 2. So this is going to be 1 over square root of 2, and that, remember, that's going to be negative. So we're going to get negative 3 pi over 4 square root of 2. Looks complicated. Not too bad. We'll just leave it in that form because that's an exact answer. It's nice and easy. So our slope of our tangent line is going to be dy dx. I'm going to use that evaluation bar that we've seen before. So dy dx evaluated at t equals 3 is going to be dy dt, which is 1, divided by dx dt, which is negative 3 pi over 4 square root of 2. And then getting rid of the complex fraction, essentially just multiplying by the reciprocal of the bottom, that's going to give us 4 square root of 2 over negative 3 pi, and I'll put the negative on top because that's traditionally what we want to do. So that's the slope of our tangent line. It looks messy, but it makes sense. if we kind of approximate here, 2 is 1.4, so approximately 1.5. 4 times 1.5 is going to be 6. So the top is approximately 6. The bottom is approximately 10. So we've got about -6/10, or -3/5. And just looking at the graph here, that matches up. That slope looks like it's about -3/5. Not exactly, but it does look like it's pretty close. In particular, it is a negative slope, which is what we got for our answer. So the next thing we want to do is write the equation of the tangent line. We know the slope of that line, but we need to know the coordinates of that point also. So to get the coordinates, we're actually just going to plug 3 into our two equations up here. So we need to know what x of 3 is and what y of 3 is. So x of 3 is going to be 3 sine of 3 pi over 4. And y of 3 is going to be, if we plug 3 in there, it ends up being -9 plus 12. No, that's not right. -9 plus 18 minus 6. That ends up being 3. That simplifies a little bit easier. Sine of 3 pi over 4. Sine is positive in the second quadrant. And we're still dealing with that pi over 4 reference angle, which is going to be 1 over square root of 2. So this is going to be 3 over square root of 2. And so the coordinates of this point right here are going to be 3 over square root of 2, comma 3. So we know the slope of that line. We know the coordinates of the point. So putting those two together, we can just use the point slope formula. And when we do that, we're going to get y minus 3 is equal to -4 square root of 2 over 3 pi times x minus 3 over square root of 2. And it's not the prettiest equation, but if you were to graph that, you could even graph it in your calculator, actually. And you can graph parametric equations in your calculator. If you want to take a little time to try to figure that out, it might not be a bad idea to try graphing those, and you can see that that line's going to be perfectly tangent to the curve.